Good morning, children. Today, let us continue the chapter thermodynamics, the last part of the thermodynamics, that is Gibbs free energy represented by capital G. Now, what do you mean by Gibbs free energy? Now, Gibbs free energy may be defined as the maximum amount of energy which is available to a system during a process that can be converted into useful work. I'll repeat. Gibbs free energy of a system may be defined as the maximum amount of energy that is available to a system that can be converted into useful energy, useful work. Now it is represented by capital G. G is equal to H minus Ts. Gibbs energy will take the two factors. One is enthalpy and the second one is entropy. Both these factors on combination will give you the del G, that is change in the Gibbs energy. What is actually Gibbs energy? The amount of the work, or we can also define Gibbs energy, the maximum amount of energy. Whatever the energy the system is having, that is converted into useful work. Energy is converted into useful work. For example, children, whatever you eat, if you eat apple, potatoes, rice, that is converted into glucose, and that glucose is stored in your body, and when you do the work, that energy is converted into useful work. So G is equal to H minus Ts, and the change in the Gibbs energy is equal to change in the enthalpy minus T into change in the entropy. Now children, regarding the Gibbs energy, three factors we have to do. Del G is equal to H minus Ts. Enthalpy is always negative and entropy is always positive. Okay. Now del negative sign minus T into positive. If it is negative, del G is negative, the reaction is spontaneous, and if del G is positive, the reaction is non-spontaneous, and del G is 0, then the reaction is at equilibrium. Okay, children? So I'll repeat. Del G is negative, the process is spontaneous. Del G is 0, the process is in equilibrium state. There is no set of reaction in either direction. If del G is positive, the process does not occur in the forward reaction. It may, however, go in the reverse direction. Okay. Now, condition for spontaneity of a process are del G for the negative. Del G would be negative under the following condition. Both the energy and entropy factors are favorable and may have any magnitude. That is, del G is negative and T delta S is positive. A second factor, when energy factor favors del H, the change is del H is negative, and entropy factor opposes the change. Money it is positive, entropy. Then the magnitude of the del H should have more than the T delta S. Then del H is negative. Now, the magnitude of the del H should be always greater than entropy factor. Then del G will be negative. Then the reaction is said to be spontaneous. When energy factor is not favoring, that is del H is positive, but entropy factor may always favors, that is entropy is positive, then the magnitude of the entropy must be much greater than enthalpy, then del G should be positive. Is it clear, children? These 3 points you have to understand. Then the standard Gibbs energy change. The standard Gibbs energy change is defined as the Gibbs energy change for a process in which the reactants in their standard state are converted into products in their standard state. Now, what do you mean by standard state? Temperature is 25 degrees C or 298 K, 1 atmosphere pressure. Okay. The standard Gibbs energy change of reaction is the Gibbs energy change when all the reactants and products are in their standard conditions. Okay. Now, like the standard enthalpy of formation of an element, the standard Gibbs energy change of an element is the standard state assumed to be 0. Then here also children, del H we did, del H is equal to summation of enthalpy of the products minus enthalpy of the reactants. Here also del G is equal to summation of Gibbs energy del G of the products minus del G of the change in the free energy of the reactants. So del G is equal to summation of del G of the products minus summation of del G of the reactants. Del G is equal to summation of del G of products minus summation of del G of reactants. That closes children the thermodynamics chapter. Okay, I'll send you the numericals. Okay, that this the del G is the last topic of thermodynamics. We'll close the chapter. Tomorrow we'll start the new chapter. I'll send all the numericals.